We are starting the next chapter, gentlemen and ladies, and it starts off with just polygons in general. Most of this chapter, however, will be devoted to quadrilaterals, bless you, specifically. But in this lesson, we're talking about the angles within polygons. And the first property that we're looking at is how do we find the sum of the angles in a polygon based on the number of its sides. So consider, once it stops bouncing and decides to open, consider, we know already what the three angles of a triangle add up to. Remember I said that should be tattooed on your soul. The three angles of a triangle add up to 180 degrees. And I have a quadrilateral and a pentagon in my diagram as well. And notice no matter how I wiggle the angles of my quadrilateral, they're still adding up to 360. Same idea with the angles of this pentagon. No matter how I'm moving them, notice that this 540, it's not flinching. Okay, but what if a polygon has 10 sides? How would I figure out what its angles add up to? That's what we're trying to come up with. So what I want you to notice is 3 angles add up to 180, 4 angles add up to 360, 5 angles add up to 540. What do you observe so far? What do you notice? Lily? It's saying it's what? No, from 180 to 360 it doubles, but if I double 360, that's 720. So your pattern doesn't hold. What do you notice, Casey? I'm adding 180 every time I add a side. Okay? But I don't want to have a pattern, or I don't want to come up with a pattern where I need to know the previous term in order to find my current term. In other words, I don't want to have to figure out what 9 angles add up to in order to figure out what 10 angles add up to. I want a formula where I can just take that number 10 and plug it in. Eugene? You're onto something, but if I do 5 times, what did you say?
180 minus 360.
Okay, that works. And then this times 4 times 360 is 720. Let's take your formula, which is valid, and let's simplify it just a tiny bit. Notice that each of these is a multiple of 180, which is kind of what Eugene was observing. Okay, so what do I have to multiply by 180 in order to get 180? 1, 2, 3, so on and so forth. Now, what did I do to the number of sides in order to get 1 here? Subtract 2. So the number of sides minus 2 times 180 is, in fact, our formula right here in our notes. The sum. Please make sure that you always look at the question, because sometimes they're going to ask you for the sum and sometimes they're going to ask you for the measure of each. The sum of the measures of the interior angles is n minus 2 times 180. And so now, very simply, I can find the sum of the angles of a pentagon, also called a decagon. Maybe jot that down too. So 10 minus 2 times 180. And do we have an answer? Someone was really, really quick with the calculator. Say it again. 1440. Okay, so please take a moment within your group and work through your turn for problem 1. Okay, based on what I am seeing and hearing, you're ready to compare your answers to mine, and I'm hearing wonderful things. Any confusion, questions? How'd I get from here to there? Do we need to see the step-by-step, or are we okay? How do you mean solve it a different way?
Like taking 1980 divided by 180 and then adding.
Absolutely. Absolutely. Very good. Right. Moving on, a little bit of vocabulary before we get to the next formula. We know what an equilateral triangle is. The same idea applies in an equilateral polygon. It has what? Equilateral. Equal sides, yes. An equilateral polygon has all sides congruent. And an equiangular polygon has all angles congruent, yes. A regular polygon is one that is both. It is equilateral and equiangular. So if we know how to find the sum of the angles in a polygon, how could I take that and then find the measure of each one, Michael?
180 times
Exactly. You take that sum and divide it by the number of sides. So exactly what he said, 180 times n minus 2 divided by that n. And I love it. He's got his reference sheet out. Notice, ladies and gentlemen, these are two formulas that you do not have to rack your brain to memorize. They're right there on your reference sheet. Okay? They're kind of in a weird place. They're in no man's land. But they're there. Okay, so make sure that you are familiar with how things look on your reference sheet. Remember that you have one. I'm loving that some of you are like, where did I put that darn thing? Okay, it's kind of in a strange place, but it is there. Okay, so that being said, let's use that formula, to find the measure of each angle in a regular dodecagon, and I'm clarifying for you, it is a 12-sided polygon. Let me pause for a moment while I'm thinking about it. Okay, 3 sides, it's a triangle. 4 sides, it's a quadrilateral. 5 sides, pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. You know that one. 9 sides, nonagon. It's right there on the screen. 10 sides, I mentioned previously, it's a decagon. 11 sides, you don't see the name too frequently, I'll tell you, but most likely you would see it as an 11gon. 11 sides is an undecagon. It's weird. And then finally, the last one that I do expect you to know is dodecagon, 12 sides. Okay, so to be clear, ladies and gentlemen, waiting. To be clear, on a test or quiz, if I'm asking you for the measure of each angle of a heptagon, please don't raise your hand and ask me how many sides a heptagon has. You're expected to know that. Lily, you had a question. Dodecahedron means, anything ending in hedron means it's 3-dimensional. So dodecahedron means it has 12 faces. Excellent observation. All right, let's come back to this problem now. The formula again was n minus 2 times 180 divided by n. Let's refocus, please, ladies and gentlemen. And I'm sure some of you were already plugging that in while I was talking about the numbers of sides. So this is 10 times 180 divided by 12. And it's 150. And take a moment, please, within your groups, your turn. Based on what I'm seeing and hearing, we're ready to compare your work to mine. We're good? Probably, excuse me. I know we're all just wanting to talk about Black Friday and Walking Dead or whatever else is crazy going on. Waiting. Get focused. We're good on the screen? Yes, ma'am. Okay. I will say probably the most common mistake that I see when students are using this formula is they do the 9 minus 2 in their head and they do the 7 times 180 and then they mistakenly divide by that 7. You need to be careful. You're dividing by the number of sides, which is 9. Did we catch that mistake? Okay. Okay, let's consider problem 3. How would I go about finding the measure of angle D? My letter D got cut off on the screen, but you have it nice and pretty on your paper. How am I going to find the measure of angle D? Don't give me an answer, give me a process. Don't give me an answer, give me a process. How will I find the measure of angle D? Yes? Okay, so step one is, it's really just going to be one of those days. Find the sum. There we go. Okay, so we find the sum. As Sarah said, we're doing 4 minus 2 times 180, and we know that the 4 angles are supposed to add up to 360. Then what?
You add up the 3 angles.
Add the known angles.
And then you subtract that from 3.
Absolutely. So our 3 angles that we know add up to what?
301.
301. And then step 3 is to subtract. So we get 59. Excellent. Take a moment, please. Work through the your turn problem 3. Based on what I'm seeing and hearing, you're ready to check your answers against mine. If my program would cooperate with me. There we go. Same 3 steps. You have to know what your angles are supposed to add up to. Add up the angles that you know, subtract, and there we are. And based on what I was seeing as I was walking around and listening, we're good. Okay, we have not, so far, all we've talked about are the angles inside the polygon. Remember, there are angles outside of the polygons. And recall, a couple of chapters ago, we talked about how in a triangle, the exterior angle equals the sum of the 2 remote interior angles. Okay, but in this lesson, we're really interested in the sums of angles and then each angle separately. So let's take a look at the sums of the exterior angles. Okay, so notice that I have the exterior angles measured, and I don't know why I didn't yet calculate the sum of them. Let me do that now. So this plus this plus this, that, And those exterior angles, notice, add up to 360 degrees. Now, in and of itself, that's a very special number to us already, but does it change? Because this is a heptagon. So if I collapse this and make it one side, well, now it's a hexagon. Notice that my sum is still 360. Let's collapse another side. Oh, well, it's not perfectly collapsed, but you get the idea. It's still 360. And if I collapse it some more, okay, well, it's not letting me collapse it any further than that. But what I want you to observe is no matter how many sides I collapse it down to, that sum of the exterior angles is always 360. Okay, so that is not on your reference sheet. So that is something that you need to memorize, that the exterior angles add up to 360. So think about it. If all of the exterior angles add up to 360, what would I do to find the measure of one exterior angle in a regular polygon? Let's say it has n number of sides. Precisely. Say that again, Alyssa. Exactly. So do I have a spot for that somewhere in our notes? No, but maybe let's add it in. So the measure, you do have a blank on your notes? Okay. So the measure of each exterior angle of a regular n-gon is 360 divided by n. So let's use that. In our last example, in problem 4, we're asked for the measure of one exterior angle in a regular hexagon, which has how many sides? Thank you. So 360 divided by n becomes 360 divided by 6, which is just 60. So finally, take a moment to work through the your turn for that problem while I am activating the Socrative quiz. And again, based on what I'm hearing, you're ready to check your answers against mine. And here's something that I want you to notice. Look at what you found here, and look at what you found in the your turn for problem 2. Look at the answer that you found here and the answer to the your turn in problem 2. What do you observe? State the obvious for us, Lily. No, that's not what I was looking for. A little too obvious there. Look at your answer. Shh. I know it's Monday. I know we've had a long break. Let's come back. Look at the answer for the your turn in problem 2. Make sure you're looking at the question too while you're at it. And what you found in the your turn for problem 4. Okay, so in the your turn for problem 2, you are finding the interior angle of a nonagon. And in problem 4, your turn, you are finding the exterior angle of a nonagon. What do you notice about their measures, Sarah? Nope. What do you notice about their measures, Michael? Exactly, they're supplementary. Remember what an exterior angle looks like. It's the extension of a side. Those two angles form a linear pair, remember. Don't forget what you already know. Okay? Is the Socrative not working? Oh, it's working.